Hello, I'm Dr. Hazel Lowe. I'm a plasma physicist working on fusion plasma diagnostics at Tokamak Energy in the UK. It's Friday the 28th of January 2022, and this is your Fusion News Update. Stories today include 1. South Korea ignites the spark of nuclear fusion hope. 2. Prototype machine demonstrates plasma compression. 3. Nuclear fusion energy device at General Atomics coming back online. 4. Joint European Torus celebrates 100,000 pulses. And I also have a couple of bonus items for you at the end. 1. South Korea ignites the spark of nuclear fusion hope. In last week's episode of Fusion News, we reported on the exciting results coming out of China's East Tokamak, which achieved confinement of a 70 million degrees Celsius plasma for more than 17 minutes. Regular viewers of our channel will know that a tokamak is a hollow metal vacuum chamber surrounded by extremely powerful magnets, used to confine a hydrogen isotope plasma at temperatures several times hotter than the centre of the Sun. Since then, the Asia Times has reported on another great success story, as Korea's superconducting tokamak, known as K-Star, produced a plasma with ion temperatures of more than 100 million degrees Celsius and confined it for 20 seconds, which is the longest that such an incredibly high temperature plasma has been confined in a fusion plasma device. This is an impressive milestone on the path to the realisation of fusion as a clean, safe and globally deployable source of energy. Yoon Si-woo, Deputy Director of K-Star Research Centre, explained that the technologies required for long operations of 100 million plasmas are the key to the realisation of fusion energy, and the K-Star's success in maintaining the high temperature plasma for 20 seconds will be an important turning point in the race for securing the technologies for the long high-performance plasma operation, a critical component of a commercial nuclear fusion reactor in the future. East has a very good capability for the long pulse operation and electron heating. K-Star has focused on the ion heating. If we combine these kinds of research together, then we can make the fusion earlier and more reliable. The team at K-Star have set ambitious goals of overcoming issues with plasma instabilities to reach confinement times of 50 seconds in 2022 and 300 seconds in 2026. 2. Prototype machine demonstrates plasma compression. Canada-based company General Fusion recently announced that they have achieved several performance goals in their prototype Magnetised Target Fusion, or MTF device, which was commissioned in early 2021. In MTF, hydrogen plasma is injected into a rotating spherical liquid metal cavity that needs to be evenly compressed, causing plasma heating to a temperature of 100 million degrees Celsius to reach fusion-relevant conditions. General Fusion has recently been able to achieve this uniform compression using a huge array of steam-powered pistons. The company stated that driving a rapid, smooth and spherically shaped collapse of a cavity created inside a rotating liquid has been a difficult engineering challenge that General Fusion has now demonstrated in this prototype machine. The company considers this recent milestone to be an important step to feed into the detailed engineering design for their fusion demonstration plant due to begin construction at the UKAEA's Culham site in the UK in 2022. General Fusion CEO Christopher Mowry explained that net energy production is essential, but not really the ultimate goal of commercialising fusion energy, which is building economical, carbon-free fusion power plants. Our unique technology, 2 decades in the making, solves the long-standing challenges of building practical fusion plants for the world's energy markets, struggling to move away from fossil fuels. The successful performance of this important prototype validates we're on the path to success. 3. Nuclear fusion energy device at General Atomics coming back online. D3D, the largest tokamak in the US, has just come back online after a 6-month break in plasma operations to install the toroidal field reversing switch, which allows the direction of the 120,000 amp current in the tokamak's magnet coils to be changed, causing the direction of the magnetic field circulating inside the tokamak to reverse. The second upgrade was the installation of a travelling wave antenna that injects high-frequency radio waves into the D3D plasma. This is expected to increase the plasma current, serving to improve plasma stability and confinement. Richard Buttery, Director of D3D, explains, "We have new tools for flexibility and new tools to help us understand how to keep the fusion plasma going. We have all these enthusiastic scientists waiting to see how all these upgrades can be used and learn more about how fusion works." 4. Joint European Torus celebrates 100,000 pulses. Last week, the Joint European Torus, known as JET, which is the largest and most powerful tokamak in the world, completed its 100,000th pulse. JET is located in the UK and is run by a team of 4,800 scientists and engineers that make up the Eurofusion Consortium. JET has been a record-breaking fusion plasma device since it was first operated in 1983, and is still the only tokamak in the world that can run using deuterium-tritium, the two hydrogen isotopes that are the most likely to be used to fuel the first fusion reactors that can supply energy to the grid. Professor Ian Chapman, CEO of UKEA, said, "JET is one of the most important machines in the history of fusion energy research. We're extremely proud to have been operating here in Oxford on behalf of the Eurofusion Consortium over the past 4 decades. Its longevity and successes have allowed us to break down many barriers on our mission to turn this ultimate science experiment into sustainable commercial power." Tony Donnay, Programme Manager of Eurofusion, said, "The recent deuterium-tritium campaign has resulted in highly interesting scientific data that will help to optimise the operation and research plan of the International ITER experiment. In close discussion with ITER, we're preparing for further experiments to be carried out in the coming years. UKAEA have made a video of the 100,000th JET plasma available on YouTube, so we'll put a link in the description below." And now for the bonus items. The location of the UK government's planned spherical tokamak for energy production, or STEP, is subject to ongoing reporting in the UK media, with 5 sites on the shortlist. While The Independent ponders whether the $22 billion ITER project really is the holy grail of clean energy, and Marketplace considers whether nuclear fusion could solve the climate crisis in an article featuring UK company Tokamak Energy. Finally, Space.com has a great piece about how fusion generates incredibly high temperatures in the sun. That's all for Fusion News this week. Please subscribe for more Fusion news and check out the links in the description if you want further information.